So I haven't done any videos on this particular refrigerator. I should have done some earlier ones because we did a hell of a repair on something like this. This is a 1928 DR-A2 monitor top refrigerator made by General Electric. It was purchased on Craigslist in Clackamas, Oregon for about 150 bucks. The gentleman that owns this refrigerator did a lot of restoration, painting, polishing, straightening some things. Anyway, it ran for, I don't know, a week or so. And then it started to go out on the overload. Kept tripping the control box, which I don't know where the hell it is right now. But anyway, that control box is mounted right here and stands about yay tall. Does all the starting, and that's where the thermostat control is. Anyway, it kept tripping, and we looked into it, and sure enough, some of the windings were grounding out. Actually, all three windings were grounding out. It'd still run for a few seconds, and then it would shut off. So the stator was grounding out, shorted. So we fixed it. We had to. This entire unit comes out of the top of the cabinet. This is right here. It's a beautiful little cabinet. I guess these DR-A2s aren't as common, harder to find. So you can see that it actually sits in the top there. There is nothing electrical within the cabinet. Everything's in the top. So anyway, it comes out. We just have a hoist there to lift it up out. And it's quite an involved project because this is the evaporator down here. It's an oven type evaporator, also called a pig, because whenever you turn it upside down, it looks like it has four little legs and a tail in the back. So that has a freezing solution in it. It's double walled, triple walled actually, because you have to consider the evaporator itself and then the freezing solution. It has a suction line on the top and then the line on the back coming from the float. It's a high side float down into the back of the evaporator. So those lines needed to be cut, and then all the screws had to be taken out of the wood here. You see that tongue and groove there? It kind of forms a box. And that had to all be dropped off, and then had to get up under above this plate, and there's a whole series of bolts that bolt this entire bell, this cast iron bell here that forms the base of the bottom of the compressor shell. This had to be removed, so this and the condenser and the entire shell came off of the deck here. And then the compressor shell needed to be split. It has 16 studs and nuts on the bottom with lead washers. Those were all removed, and then it separates at about right here, right below this area right there. And the top of the compressor shell and everything comes right off, and then the compressor itself sits on springs on this base. And then the stator is right on the very top, the rotor in the center, and then the compressor is slightly below that. That only took 4 small screws to be removed, and then that popped right off after desoldering the 3 wires. They run, start in the common wire. That was sent away for rewinding. A few $100s later, got it back. We cleaned out the inside real well with brake clean, put the stator back on, routed the wires down, soldered them in place. And of course we had to solder the wiring for the bottom at the under the glass leads there. Anyway, today was reassembly, putting it back together. Installed a liquid line filter right here. I think it's a 3 cubic inch filter. This line from the condenser originally ran right into the float there, so that required a little bit of rerouting. Another gentleman, I think in Indiana, did something similar, but he used little 90-degree elbows. I bought some, couldn't find them for this project, so we had to fashion this, which I kind of prefer because it's more of a sweep. It's a little nice looking. It was very difficult to do, to get everything to be lined up. It was a lot of bending and checking and bending and checking and cutting and throwing away, and went through several iterations of these here, but it came out pretty well. I did add a low side Schrader valve here. This is just a piece of 5/16. Well, it's a 1/4 inch ID. It's designed to slide right onto a piece of 1/4 inch. So the original charging stub was here. So went ahead and put one on it to make charging easier. We're probably going to charge as a vapor. And yeah. Oh, and of course, if you haven't seen one of these before, this is a service valve kit for a number of refrigerators in the 1920s, 30s, 40s. Kind of went away from this with completely hermetically sealed systems that don't have any access at all. So this gets mounted on, and there's a Bristol key that goes down into a little plug that plugs that line. So this is what the kit looks like. The rest of the kit. This is a little hand wrench Bristol key. You can get that to focus, but very unusual. And a number of different adapters for various different refrigerators. So we're evacuating right now. I was down at around 1200 microns after about 10 minutes. So we're hoping for the best. The shell is assembled with a lead seal. When we pulled it apart, part of the lead stuck to the upper shell, part of it stuck to the bell. There's probably about an 1/8 inch wide square groove goes around the top of that bell. And so when we first removed the stator, I reassembled everything and then pulled a vacuum, put nitrogen in there to prevent everything from corroding while the stator was being rewound. And it actually held pressure, just being clamped back together without even really torquing anything to any specification, just tightening everything. So that was kind of cool. But with the reassembly, we dug all the old lead out and then put in some 1/8 inch round lead wire, essentially, that I drew straight and then beveled and laid it in there, tapped it in place. And then whenever we reassembled it, we tightened everything to 30 foot-pounds in a star configuration and pressure tested, and seemed like it was okay. It was at 61 PSI, and a week later it was at 57, but that's with attaching and reattaching the hose. So a little bit of losses could have occurred there. So we're hoping for the best. In order to get this thing back to running condition, we have to line this up here a little bit. Gonna have to tweak this a little bit to get these holes to line up. Put those screws in place. Clean it up, obviously, finish the wiring here, put the control back on, which is a really neat little device. And here in a few days, hopefully we're going to charge it. I do have a 30-pound canister of R124. This is replacing the original refrigerant of sulfur dioxide, which was removed and passed through a bucket of lye water. It takes several pounds in order to charge this machine. R124 should have similar enough properties to sulfur dioxide, according to some experts in the various parts of the country. The pressures are similar. I think the specific volume of vapor is similar. So the large capacity displacement of the compressor should be accounted for with a lower specific volume vapor, as opposed to a higher pressure refrigerant where it would be handling a lot more mass flow for for every displacement, and potentially overloading the motor. So yeah, so that's where we're at right now, and maybe if I get the thing back up and running, we'll take another video. Thanks for watching.